the relation between mass and inertia. We have already discussed this. Mass as a measure of inertia. Larger the mass, larger is the inertia. Smaller the mass, smaller is the inertia. Okay, please explain. Pritesh, please turn on your camera. Yes, Pritesh, can you explain this?
Uh,
Mass as a measure of inertia. Everything is written here on the screen. You just have to give
yes.
example or you can
If the
explain.
large, if the larger the mass and the larger inertia. If the small,
Larger the larger the mass, larger is the inertia means the ability of the object which has greater mass, the tendency of the object to stay in its state of motion. The one with greater mass has more tendency. No? And the one which has greater mass can resist the change in the state of motion. No? And the objects which have smaller mass, they have less tendency to resist any change in the state of motion.
yes.
All right. And when I had explained this to you in the previous class, I had given you one example that there is a hill and you are standing at on the ground. And what happens? We have taken two different objects.
Yes, ma'am. It is easier to
Or
stop the
big rock and the small
uh,
stone, a rock and a
while
small
the big
stone.
one has
And they both are
larger mass and larger inertia.
both were sliding down. No, this we had discussed. No, this example we had taken in the previous class, and both are sliding down the hill. And you
Hmm.
want to stop both of them. Then which one is easier to stop?
Small one.
Smaller one.
Smaller one.
Because it has less mass and therefore less inertia. So its tendency
Yeah.
to stay in its state of motion is less as compared to the heavier object. Heavier objects are difficult to stop. Okay.
Yes, ma'am. Hmm.
So next is Newton's first law of motion. Please write the heading in your notebook. Newton's first law of motion states that every body continues to be in the state of rest or of uniform motion along a straight line unless or until it is compelled by some external force to change the state. Means if there exist no unbalanced forces acting on the object, if there is no effective force acting on the object, then the object which is at rest will stay at rest and the one which is moving will continually move with a constant speed along a straight line unless or until it is written here that it is compelled by some external force. So if no external forces are acting on the object, then the state of motion of any object does not change. Okay.
Hmm.
So this law is also called as law of inertia. We call this law as law of inertia, and this we had discussed in the previous class as well. What does inertia mean? Inertia means that there is a natural tendency of objects to keep on doing what they are doing. Okay, so they resist the changes. All objects resist change in the state of rest or of uniform motion, and objects keep on doing what they're doing means if the object is at rest, it will stay at rest.
Is
If it is
yes,
moving, it will
stays
continually.
at
Yes, so let's study the skater to understand this a little. What is the unbalanced force in this figure? This we have discussed, this example we had taken in the previous
rest.
class
A
as well.
rock is a rock is stopping a skateboard.
Hmm. So what happened to the skater in this figure? It stops after some time. It
Yes,
changes. Is
and it
the
stays
skater
at rest.
changed his state from motion to rest? So there is an
Yes,
unbalanced force acted on him in the form of an obstacle. So there was an obstacle in his path, and the skater stops. And because what happens here? Why did he fall?
because he was in motion um and there was an like obstacle
Stops the
in his way.
skateboard.
A rock that stops his that stops his motion
Yeah.
from
Hmm. The stone which was there on his path, that stone or the obstacle we can say, stops the skateboard. Skateboard stops, but the skater is still in the state of motion, right? So to resist
Hmm.
the change, he falls in forward direction. Okay.
Yes, ma'am.
So inertia can be classified as inertia of rest. This we had discussed. Inertia of rest is the inability of a body to change its state of rest until and unless an external force acts on it. Means if the object is at rest, it will stay at rest. It will not change its state of rest. Inertia of motion means the inability of a body to change its state of motion until and unless an external force acts on it. जब तक कोई एक्सटर्नल फोर्स नहीं लगेगा, अगर कोई ऑब्जेक्ट मूव कर रहा है तो वो कंटिन्यूअली मूव करता रहेगा. ठीक है. Third, inertia of direction. It is the inability of a body to change its direction by its own until and unless an external force acts on it. Means object resists the change in direction as well. So being aware of Newton's first law of motion, we should wear a seat belt in the car. Why should we wear the seat belt in the car? You can see, look at the.
Because we can fall if a car is bumped into a wall or a tree
Mhm.
due to inertia of motion.
Yes. First law talks about how to overcome inertia when an unbalanced force is applied. So now we have questions based on this. Which law of Newton is called the law of equilibrium? First law of motion, second law of motion, or third law of motion, or law of gravitation? Law of equilibrium means it's about the equilibrium forces acting on the object. It's about the balanced forces acting on the object. It's about the net force acting on the object.
Newton's law of gravitation.
See, we are not talking here about the attraction between two objects and why does Earth revolve
The
around.
first one, first law of motion.
Yes, its answer
First,
is correct. It's Newton's first law of motion. And we know what Newton's first law of motion states. Every body continues to be in the state of rest or of uniform motion in a straight line unless compelled by some external force to act on it. Next question. You are thrown outwards when your car suddenly takes a turn. Which law of Newton is involved in this?
first law. The second law, third law.
It's about first law only.
First law, inertia of direction.
Right. Next topic is friction. So what is friction?
The force
Friction.
acting on the object.
Friction is the opposing force that comes into play when one object moves or even tries to move over the surface of another object. Means because here we say that no object is perfectly smooth or ideally smooth. There are irregularities present on the surface. And when one object tries to move over the surface of another object because they are not perfectly smooth and therefore irregularities get interlocked like this. This we had discussed already. And we need to
Hmm.
apply force to cut through the irregularities, right? So that the object can easily move. And for this, we need to apply sufficient force on it so that it can overcome the frictional force acting between the two objects, right? So if you're applying force in certain direction, then frictional force acts in the opposite direction. It is a self-adjusting force. It always opposes the relative motion between two objects. Okay, and cause we have discussed already. It arises due to the irregularities between the surfaces at contact, and force of friction develops at the surfaces of contact of two bodies and oppose their relative motion. This we have discussed already, right? Next,
Yes.
friction arises due to irregularities. Why does friction arise? It is because of the irregularities between two surfaces.
Follows
Irregularities
this.
interlock into one another, and these interlockings stop the object when an attempt is made to move it. And so we need to apply force on the object to make it move because the applied force overcomes the interlockings. It breaks the interlocking so that the object can move smoothly on. another surface. And if the number of irregularities is greater, force of friction is also greater. Means more roughness, more friction. Right?
Yes.
If the surface is not very rough, if the surface is quite smooth, then force of friction is less. But if there are large number of irregularities, then surface is quite rough and therefore force of friction is also greater. At times, the surfaces that appear to be smooth also have minute irregularities. Sometimes we feel that, yeah, it is quite smooth and slippery, but it is not very, it is not, we cannot say that it is ideally smooth or ideally slippery. It is frictionless. These terms we do not use because ideally it is, ideal conditions are not possible. And practically, no surface is perfectly smooth and or absolutely frictionless. It is impossible. Okay.
Yes, ma'am.